Hi guys, welcome to Math is Fun with Amateur. And for today's lesson I'll be writing on my notepad, so I'll be a bit slower than usual. So for today's lesson, we'll be doing addition and subtraction. Addition and subtraction of algebraic expression. So this is our lesson 3. So the main focus of this topic will be on grouping like terms. Okay, so from lesson 1 and 2, we've touched on what terms are, what expressions are. So when we see expressions, algebraic expressions, we know what we are talking about. When we see terms, we know what we are talking about. So just a quick recap. We said terms are separated by signs of operation. So for instance, if I have a term, say, if I have, say, 3a plus 5 plus 6a minus, say, 4. This whole thing we said is an expression. Just a quick recap. We've done this in our lesson 1. So we said this whole thing is an expression, an algebraic expression. And each individual numbers or combination of both separated by signs of operation. So this is a sign of operation here. So this sign of operation is separating 3a from 5. So because the sign of operation is separating it, this becomes a term. This is also a term. This is also a term. And this is also a term. So in this expression, we have 4 terms. Good. So then when we say grouping like terms, it means we'd have to find terms that are similar. Let's just jot down. So similar terms. So when I'm explaining this concept, I like to use the term family members. So grouping things that have the same family member, sort of, for you to remember, or just something for you to play around with. So let's take some examples now that you're familiar with grouping activities. So if you've been asked to add 2x plus y plus x plus 4y. So now we're doing the addition and subtraction. Don't forget, I told you when an alphabet stands alone like this, it has coefficient of 1. So this can be rewritten as 1y, just for your understanding. And this can be rewritten as 1x, just for your understanding. So plus 4y. So now grouping means we would have to move each of them to the other side to come and meet each other. So we have 2x here. So we'll check through the expression to see if we have a like term. So when we check through the expression, which one looks like 2x? Or which one has the alphabet x attached to it? We see this x here, which is the same as 1x. So plus 1x. Then we start from this y plus 1y plus 4y. So when we are adding or subtracting, we just need the numbers. So sorry, here we have 1 and here we have 4. So 2 plus 1 is 3x. 3x. 1 plus 4 is 5y. Grouping like terms. 3x and 5y are not the same term, so we can't get 8xy. It is not done. So this is our final answer. Okay, let's take another example. So if I have, so let's use the z. So z example 2. So b. Let me take different pen. So b. So sorry. So example 2. So if I have 3z plus 6x again plus 2z plus x. So we need to group like terms. So 3z here plus 2z, because this and this are like, plus 6x here, x is here, plus x. So now we can do our addition. There is a hidden one here. So just for your understanding, so 6x plus 1 plus x is the same as 7x plus 3z plus 2z is the same as 5z. Final answer. Okay, so now this is much more easier. When you have addition, you don't need to be extra cautious. You just have to find the like terms and then you group them. But when it comes to subtraction, extra care needs to be taken when it comes to subtraction. So now let's find a way of introducing subtraction into our example. Okay, get my pen. So for example 3, we're introducing subtraction here now. So I start with 3x minus minus 5y plus, can make it minus 2x plus 3y. So in this case, I am grouping the like variables together. But now note one thing. Remember when we were doing the lesson, okay, I think in lesson 2 or lesson 1, I really can't remember, but I talked about this, that when you're moving them along the expressions, you carry the signs of operations. So for instance, we have just 1, 2, 3 visible signs of operation. There is nothing at the first point, but we have 4 terms, and we said signs of operations are what separates the terms from each other. But take a look at this. So meaning each term is supposed to have its own sign of operation. But this 3 here, a mistake that can be made is we assuming this negative affects this positive 3x. But in real sense, it doesn't. This 3x becomes positive 3x. because I made mentioned that was lesson 1 that if you have a term standing alone without a sign preceding it, there is a hidden positive sign unless otherwise stated it's negative. So in this case, this is the same as positive 3x minus 5y minus 2x plus 3y. So with this, each of the term has its own sign of operation. So now we can easily move across the expression. So we have positive 3x, then minus 2x comes here. So this minus is following the 2x, anywhere it's going to. Then this minus is following the 5y, anywhere it's going to. So we move this minus 5y. This positive is following this 3y, positive 3y. Get it? So 3x minus 2x. This gives us 1x. Because 3 minus 2 is 1. So 1x, which is the same as x. I don't expect it to give me a final answer as 1x. It's not done anywhere. I just introduced the 1 to assist you to understand the whole concept. So we have x here, then minus 5 plus 3. So this is addition and subtraction of integers. So minus 5 plus 3, this will be for another lesson. But having minus 5, it means I am sort of owing 5 cedis, for instance. So I'm owing 5, and then I've decided to go and pay 3 out of the 5 I was owing. So the question is, am I still owing, or I have settled my debt? In this case, I'm still owing a 2. So the answer is minus 2y. So this is our final answer. No other addition. It's an expression, so there is nothing else we can do to this. Okay. Now let's take another example. So negative t, let's put the red. Negative t plus 6s, this is s, make it smaller, minus 2t minus 2t plus, okay, minus s. So grouping like them, so now we can see a negative precedes the t. So in this case, we have our 4 expressions complete. So this is perfect. So we just have to do our groupings. So we group where t's are. So minus comes here. Then we have plus 6s here. Then we have minus s here. Simple. So minus here. So I'm owing t, I'm owing 1, and I'm going to borrow an addition of 2. So me owing 1 before and I'm going to borrow again gives me total borrowed amount of 3t. So now this is 6 minus 1s. This is s. This is s. So 1s. This is s. So 6s minus 1s, that is 3t plus 5s. Final answer. Okay. So this was our example 4. Okay. So this is just basically addition and subtraction of algebraic expression. So I hope you enjoyed it and do have fun practicing the examples I'll give you in the next slide. Thank you.